world before data science and after data science, I'm sure you must be grappling with this fact. Data is the new oil and all those statements you must be coming across. Well, there is no clear differentiation between how the world was there before in terms of data science lens or how it is now. But yes, definitely one key difference, the way I understand it, is that in the world before, so-called a decade back or so, data was the byproduct of any business process, right? So since you were visiting a hospital, you were purchasing purchasing at a kirana store, your data was being recorded just for the sake of it. It was just passively being collected, and it was not being used much. In fact, to the extent, just to give you, contextualize this thing, is that if you did not get good marks in your 12th standard in the PCM, right, you were just not eligible to even attend an engineering college, right? Your parents would not trust you and things like that, right? So that was the status data had. and things are changing, I'm sure, in the education space as well. Is that this is a kind of counterintuitive example where your parents were trusting the data so much they were not trusting you, and in the education system we are taking this as a trajectory where we are trusting human beings more than data. But the opposite is also happening, right? Where in the now world, data is becoming the raw material. It's kind of driving every decision. And so before we get into the real meat of the session, right, I want you to be, guarding yourself against two extremes of where data can and should not be used, cannot be used, kind of extremes, right? So one extreme is this, where, this 8-year-old kid is asking if we can afford a computer, and the father says, you do my taxes, right? You have the data, you yourself figure it out, right? So that's the power of data. It reduces a lot of controversies, it reduces a lot of disputes, right? On the other hand, on the other extreme is something like this, where, you might just break up with your girlfriend, right? Just because you preferred using tabs in your code and she uses spaces, right? So you are trusting data so much that, even this kind of difference between you may affect your emotional and romantic relationship, right? So these two extremes make the entire spectrum, as I see, of data science, right? Okay, so I hope that warms up all of you, that context, and having that as a very broad spectrum in which we should be making sense of data and data science and various tools and all those things that we'll cover in the rest of the session. Okay. So let's again, without making it too much complicated, right? We'll not go into defining what artificial intelligence is and when it was invented in 1950s or 1850s, right? We'll get a very quick, broad sense of how the rest of the world, defines and differentiates between how AI is today, which is what we call artificial narrow intelligence, because it has very limited capabilities. And then there is something called artificial general intelligence, and further than that is something called artificial super intelligence, right? And then both of these, which are kind of grayed out, are the things of future, and people have kind of their own projections about, which era would finally we'll be able to witness artificial general intelligence, or even artificial super intelligence, right? And super intelligence is really where machines become much more powerful than human brains themselves, right? But that's the complexity of future. So confining ourselves to what we have to deal with today, which in itself is quite complex, although by definition it is narrow, but that this narrow band itself is quite complex, right? So at the outset, this is how people, this is how generally we make sense of what artificial intelligence is, which is like one universe of problems, which somehow, if a machine is able to solve, can make it feel smarter, right? So that's a broadest set of problems. And within that, a subset of that artificial intelligence set is what we call machine learning, right? So the rest of it, which is not covered by machine learning, are very generic algorithms, and in your, for all practical purposes, unless you are specifically interested, right, you are not going to deal with those class of problems. Most of the times when you think of learning, either out of either in your curriculum or otherwise, you are going to deal mostly whatever is there within the universe of machine learning, right? And a super specialized field within machine learning is what we call deep learning, right? Now, I'm sure this is not new. You must have seen this kind of diagram, right, at many places. And I'll not make it more complicated than this. And in the rest of the session, I'll not be using this as a tool as such, right? So this is where it ends, just to avoid, just to bring us all on the same page, because this is what most of us and almost all of us are aware of. Okay. Now, I think big question that was coming in the questions that you had filled up, and with my conversations with the organizers of the event, is how do I differentiate between so-called now I can get a sense of one is the subset of the other, but then the very confusing part is what is called data science / machine learning, right? And these are the words that are used interchangeably, almost synonymously, and you would never really put any efforts to differentiate between them, right? Even the best of the courses, commercial courses that they are that are out there, they'll not try to differentiate that, right? So I thought I'll declutter that for you to some extent, and so this is how I think we can differentiate machine learning from data science. So let's have a look at first what data science is. All right, so let's understand what machine learning is, right? So machine learning is essentially about thinking of how machines can learn, right? And the three sets and subsets that we just saw, right? They are just different paradigms of learning, right? About how you learn. Should you be learning from should you be learning from past data, which is what we usually call supervised learning? Should you be learning from no data, which is what we call unsupervised learning? Should learning not be dependent on anything but your actions and how desirable they are, right? That is what roughly we call reinforcement learning. So these are like various paradigms of learning, and as we speak, every month or every quarter or so, right? Very frequently there's a flood of different learning paradigms, and we'll talk about that complexity in a bit. But other than these learning paradigms, what machine learning deals with is about how to optimize algorithms. So this is where it becomes, where it comes very close to people who are living and coding algorithms, which are people from computer science and people who know programming otherwise, as to how best you can run an algorithm in shortest possible time with using very little computing infrastructure, right? So that kind of optimization, right? And the third part is the interoperability, right? So once you have, so algorithm is nothing but a logic, right? Logic in its optimized form, optimized for the compute infra that it requires, right? Now you care about how easily and how seamlessly can I make it interoperable in as many environments as possible, right? So for one algorithm, you will find its implementation in R. The same algorithm, you will find its implementation in Python. You'll find an implementation in a commercial tool. You'll find an implementation of the same algorithm in an open source tool, right? So this is about creating libraries and aligning whatever logic that you have figured out today with other environments. Okay, and rest of the machine learning, what we know, right, is about modeling, right? So how an algorithm performs on data, and which data is best aligned with what kind of algorithm. That sort of mixing and matching is what rest of the machine learning is about. Now, let's contrast and compare, and let's see how much this overlaps with the so-called science of so-called field of data science, right? And data science we could sort of place like this, right? So the modeling part of data science overlaps with machine learning, but data science, if you think, right, horizontally it has multiple components, right? And let's quickly talk about each of them one by one very briefly. So data science is about solving a problem using data, right? So what data science does is that it starts from the left. If you notice, it starts from the business problem. What are you trying to solve, right? Are you trying to, increase subscriptions of say Netflix users? Are you trying to prevent people who are unsubscribing from Amazon Prime? What is the problem that you are trying to solve, right? How well you can articulate it. So this is like one step. Second step is, okay, fine, you want to solve a problem, but do you have enough data for it, right? So if you just started a company, it's just 2 months old, you just don't even have enough data for a supervised learning algorithm to model a use case, correct? Or even if, it's not always about sufficiency of data, but it's also about the quality of data, the richness of data. So is data even available? That is the second question that we usually deal with, right? And then third, so second you do data sources, and then you deal with the data quality and sufficiency issues, and then that comes the modeling part. And that, of course, is quite complex in its own, right. And then the data science thing does not stop. After modeling, you have to deploy the model in the production environment. And then again, to give an analogy, this is very much akin to how we usually deploy, softwares, typical classic softwares in the production. But what happens after production in softwares is more of an error reporting, which is just any errors in your classic softwares, they are going to come back to the same developer. But here in the world of data science, after a model is deployed, monitoring that model requires again multiple people, who might be concerned about the performance of data, right? So the data monitoring part again is much more complex. The model monitoring part, is much more complex in the world of data science. Okay. Again, I know I've done it very briefly. We'll try to cover some of these aspects in a bit more detail in the later slides. But this is how you sort of differentiate at a if you wish to. Otherwise, the rest of the world does not, right? If you want to remember, right? One takeaway from this slide is that in data science, what is important is data, right? So you start with the question of data. What is one data bit that you want to improve? Is the data available? Is the data good enough? Can we model the data? What is the best algorithm? How do we deploy it? How do we monitor it, right? So entire this horizontally, if you see, in data science, what is more important is data, right? In machine learning, what is more important is learning, right? How can machines learn? So it's less focused on machine, but more on learning, right? So it talks about very different ways of learning, and this is like ever evolving. Every day you have to be very, very alert to keep up with the pace. Various learning algorithms and even different paradigms are coming up. Okay, so yeah, one, they are not synonymous, and second, you can choose, right? You could choose to be a data scientist, not be a some machine learning expert, right? Okay. So again, let's follow up a bit on the landscape of machine learning. What are algorithms that, what are various machine learning algorithms that are available? And like I said, this is just things are, this is how I could think I would be able to plot all of them in a single slide, because if we start talking about each of them, they are like different courses in themselves, right? But if you look at this clutter, right, this is how complex it looks, and every month or so you'll find some research paper who's talking about some new kind of learning. So you have supervised learning, you have semi-supervised learning, you have transfer learning, adversarial learning, ensemble learning, online learning, active learning, semi-supervised learning, batch learning, right? So it becomes confounding, and it can become as confounding as this guy, and you feel that confounded, that confused, right? And of course, one cannot be expected to learn and keep up with all of that is happening in the area of machine learning unless you are a researcher there, right? So what I thought, I'll present a relatively simpler and much more manageable view of how you can make sense of different learning paradigms and algorithms that are around us, right? So again, in the attempt of not becoming a Vinod, I tend to divide this entire sort of machine learning spectrum into 4 boxes, right? And quadrants are easy, right? Everywhere, starting from coordinate geometry, the day we start learning, much of the oversimplification. Of course, this hides a lot of complexities as well, but then this makes somehow things very, very manageable, okay? So the capabilities or the so-called smartness or the so-called intelligence that different algorithms are able to create for us, I divide them into 4 boxes. One is there are sense making, prioritization, guesstimates, and generative capabilities, right? So let's quickly talk about them one by one. So one is the sense making, right? The sense making capabilities of machine learning are about what it is. Telling something what it is, right? So when you have a face detection algorithm, face recognition algorithm, telling what telling a self-driving car is being able to detect an object. If there is a big Wikipedia article, I want to make sense of it, right? So can you summarize it for me, right? Or if there is a customer care complaint, tell me the mood, right? What is the topic? Is the person happy? Is the person not happy? Is he complaining? Is he being sarcastic? And all those things, right? So sense making / perception is all about if the algorithm has some capability of telling me what it is, right? It could be any of these, and these are just few examples. And I can tell you, as you figure out more things, something new which you think, you eventually would be able to place that new capability in one of these quadrants. Okay. Now, next is about prioritization, which is telling about the algorithm is able to tell here about what is good, what is bad, kind of problems. If an email is spam or not a spam, right? That's how Gmail does. Gmail sort of filters some of your emails as spams, right? So that's about being differentiating between good guys and bad guys. A more familiar example of this would be Google search results, right? So if I and you search the same thing, Google search is going to give me a different sequence than what it will give to you, right? Or your Facebook feed or Twitter feed. Of course, the number of variables are different, but this sorting, you would be able to see this sorting on similar parameters is very, very different. What we call personalization, right? The essential capability there is prioritization, correct? So depending on who you are, who's searching this thing, whose friend list it is, who's shopping on Amazon, it is able to give you your version, the sequence that is best optimized for you, right? And similarly, there are segmentation, these are high revenue customers, these are low revenue customers, these are potentially fraudulent customers, all these kind of segmentations, right? And even online dating, right? To the extent of just this thing, again going to the extreme right, the picture that we saw in the previous slide, is like, again, it is prioritizing rather than I deciding who's best for me, to date with. The algorithm is telling me, right? Again, it's a prioritization. You should date this candidate, not this candidate. Correct? Now, the third quadrant is of guesstimates. So this is about making an informed guess, right? Based on what you know from the history, and this category is really mostly about supervised machine learning capabilities. And the kind of questions that it can answer, this quadrant can answer, or the algorithms falling under this quadrant can answer, will be like, how much will this customer pay, right? So there are instances of dynamic pricing in many businesses, right? So what is the best price that I quote to the customer so that the customer is willing to pay almost instantly, right? Or the instances like weather forecast, what is going to be my sales volume next month, next quarter, right? Or if you are going and applying for a loan to a bank, right? How much loan should I give you, right? I'll approve a different amount of loan to Malika and then say Gaurav, right? Because both of them have different credentials, for instance, right? So that's the guesstimate I'm making, about how much. So it's usually a quantity, mostly quantifiable variable that I'm trying to guess. And the fourth now is the quadrant of generative capabilities, right? So here you would be able to place the kind of all of you, I'm sure, must be aware of the recommendation engines of Netflix and Amazon and all those things, right? So based on some amount of data, the algorithm is able to generate, right? Either some options based on if you have purchased this, browsed this, here is what this person must be interested in next. Okay. In the world of, say, natural language processing, right? And this is a recent development, right? These algorithms can even write fictions. They can write full-scale novels, and then you will not be able to differentiate whether they are real or created by an algorithms, right? And another category in the again generative quadrant is the so-called deepfakes. I'm not sure if you know about it already, but there is something called generative adversarial networks, and deepfakes are going to be a big nuisance, right? Because they can manipulate images so easily that they can just deceive as if they are genuine and real, right? So this is again image generation kind of capability, right? And summaries we talked about in the sense making quadrant, but yeah, summaries is a kind of also a kind of generative capability, right? Where one complex research paper, one complex newspaper article can be just summarized in a few lines. Okay, so this is what I thought is a relatively manageable way of making sense of this complex world of machine learning. Now, that's it. Again, we are not going. Okay, last bit is the world of automated ML, and then this is quite dear to me because this is what I work in every day. And this automated ML is about, it kind of cuts across all these quadrants, and this is a very emerging field, and its mandate is actually cutting across all those four quadrants, right? What it does, it's not a new capability, it just tries to automate as much as possible from each of these quadrants. So that's in the simplest terms what automated machine learning is. Okay, so yeah, that's it. 4 quadrants and fifth, the world of automated machine learning. Let's not go in more details. Let's talk about something interesting. Okay, so again we are back to the world again. We are synonymizing data science and machine learning, and let's see the kind of roles that exist, right? While thinking of this section, again, I had spent a lot of time thinking about, thinking from your mind, is that when I think of roles, I'm sure not all of us want to, get a data science job right after a graduation, right? Some of you will try to find a job, not necessarily in data science, but yeah, if possible in data science. But there would be many of you who will go for MBA, pursuing MBA, right? Some of you might go for law. I've seen people, some of you might go into public policy, and some of you might just not do anything, just get married and, become a housewife or a house husband, yeah, just to remain gender neutral, right? And in all of these roles, right, data science and machine learning is going to come to haunt us, right? So while thinking of what kind of roles exist, I had all these sort of aspirations and career paths in mind. And since data science and machine learning is going to be a horizontal in the sense the way electricity or oil is today, hence it is important for us not to learn about these roles only from a money earning and employment perspective, but even to deal with this world as a user, simple user, or even a consumer. Okay. So there are many roles, and this is quite complex. Let's see the roles one by one. Okay. So now, at the core of this is this set of roles, and don't be be intimidated by these CXO kind of roles. What means is that people who are in the position, people who are domain subject matter experts, and who are in the position of framing problems, right? So usually, in a smaller company, usually use cases and what to work in and where to employ machine learning, these kind of decisions are taken usually at the CXO level. But yes, in the bigger companies, they could be happening at a relatively lower level. But titles being immaterial, right? This layer, this role is essentially of the people who frame and think of various places where machine learning can be used. And this is, Gaurav is here, he knows, people in the decision-making positions. As of today, machine learning is not utilized to the extent it should be, right? So these are the people, Gaurav is talking almost on a daily basis, right? Talking to these people, facilitating their thought process of, okay, you can use machine learning here, you can use also here, you can bring these kind of efficiencies and all those things, right? So one role is this role, which is of decision makers, okay? Now, the next layer, and this is in no particular order of importance or salaries. By the way, I'm not going to cover any kind of salary distributions and what kind of projections are there, 20%, 22 CAGR and all those kind of figures. This is just a simple enumeration of the various kind of roles that exist in no particular monetary or otherwise order of prestige or any kind of that thing. Okay. So the next role is of data engineers, and if the data volume is big, you kind of also hear a sort of closely known name of big data engineers, right? And what these people are doing, they are just managing the data that is coming from different business verticals. They are making sure that it is manageable, it remains manageable, and finally it remains available to the rest of the organization in the form of very simple tables. So this is technically known as a data lake, and from that lake, depending on how much data and which data you need, you could simply be scooping data for your requirement. So this is the role of data engineers. Now next is what you usually know, and we talked about what a data scientist or a data science world look like. So this is what we know, what we usually all of us talk about, we think of, right? Then when we say a job role in data science, right? So this is data science, and next related to this is a kind of sister role, which is of data analysts, right? And even data storytellers, right? And if data scientists, like the way we saw in the previous slide, if they are the people who are owning a problem from the problem formulation stage to modeling to post modeling, all these stages, data analysts are more into understanding what it says, right? And the guys, storytellers, they are into articulating what it means, what it could possibly mean, right? They are into the world of creating, say, good, creative, and more comprehensible dashboards, right? So this is a sister role here. Now, next is that of users, basically, right? So software engineering, software engineers and business analysts, these are the kind of roles that existed even before data science was so prominent, right? But now they become users of what data scientists are producing, right? So they need to know how and what data scientists work, and they need to be able to consume whatever API or whatever models that a data scientist could possibly be building. And application, an application software engineer should be able to understand how a model works and how to utilize that data, how to incorporate that into an application software, right? So this is again not a core data scientist role, but then it has to take cognizance that, okay, there is something called data science and I need to learn a few more things. Okay. Now there is another role called machine learning engineer, which is a little tall guy, who kind of knows both the worlds equally well. So something like what we have, the role of a full stack developer within the realm of software engineering. Here, a machine learning engineer would be somebody who knows data science as well as he knows, software engineering. Right? Who can code, who can perfect algorithms, who can also get his hands dirty with the data and create models. So sort of a hybrid role. Okay. Now, next role is that of a UX or information X, IX, so-called information architecture designers, right? So again, this could be, one of your super specialization area, right? After graduation, many of you might want to go in the field of industrial design and user experience design, right? And might go for a master's degree there. And not that UX did not exist before data science, but again, like the world of software engineering and business analysts, UX for an AI application is very, very different. So you better need to understand the kind of anxieties, the kind of emotions a user has when he's dealing with a machine learning system. Okay, and yeah, I could go into many more details, but then let's complete this list of all the roles first. Let's be brief about each of them. Now, the next role is, these are basically two roles. Okay, so on the right, what you see, basically this dotted line is market, in the sense, if this is a company, right? The guys who are right there sitting in the market are one who are selling and sort of making the rest of the market aware about the product, which is the sales and marketing people. And a counterpart of them is the procurement people, right? Who are procuring products from the market for the company, right? For some other purpose, right? Now, both of these categories, they are again users of this data science world. And Gaurav is here. He'll be best to tell what it means to sell an AI product. What it means to be selling a full stack machine learning services capabilities, right? If you are not aware as a salesperson, as a marketing person, of how machine learning works, right, you would struggle a lot. When you go out, talk to the customers, right? Similarly, if you are in the procurement domain, you'll be talking to multiple vendors. People would be coming telling you, this is how our product is good. The product has so many capabilities, and this metric, this optimizes this doesn't do this, and to give you sort of concretize this, one of my batchmate, he's in the retail, and he's recently completed online machine learning certification, just because everyday basis he's being offered one or the other product which claims to be a superior machine learning product, right? So for him to be able to make sense, he had to do this short online course for himself, so that he can make sense of what it is, right? What this particular metric means, what actually makes a machine learning product superior. Okay, so let's move next. Now, next role is of an AI product manager, right? And this again, another tall guy, right? His area of not really expertise, but his knowledge spans all the way from sales and marketing to UX UI to data science to data engineering, right? Even up to the extent of problem formulation, right? These are the roles. These are the people who are generalists and are building products for this data science world, right? Now, there is another generalist role which is called the AI consultants, right? And these consultants, if you see on the left, they are available for solving very specific problem related to AI at various levels, and they are available in all sorts of packaging and size and rates and prices, right? So these are the consultants who are usually experts into some of them would be modeling experts, some of them would be UX experts, some of them would be more at the data engineering level, and depending on where you employ them, you have a range of options to choose from. And this is again another generalist role, but again, even at the margins, you have to wherever you are, right, at whichever level you are, you have to be careful that you know this world quite well, right? You usually don't work with a specific product or specific company. You always are working on different use cases, different business problems, helping organizations frame their AI problems, helping them figure out what is the return on investment, what are the precautions, what are the things that they should be taking into account while undertaking a machine learning project. Again, consultant role, I'm sure you already know, but this for the AI world is a different role, right? Sort of colored with AI. Okay. Now, next is the miniaturized sort of version or super specialized version of this product manager. There is something called data PM, and these are the people who are working on a day-to-day basis with data analysts and storytellers, and they are figuring out, okay, we could, this is what the data is telling, and maybe this could be a good idea to invest in building a product, right? So this is a little more specialized role called data product managers, right? Now I think this is the picture of the roles that you must have already seen so far in one form or other, right? But now there's another sort of categories of roles which is emerging, and you won't see much of it, but if my guess is correct, you'll see much of it in the coming years, right? Coming 4-5 years. So one of the roles here is that of data labelers, right? So if again, I'll explain this a little bit, is that in the world of supervised machine learning, right, you have to have labeled data, right? You should be able to tell the machine upfront, okay, this is a good guy, this is a bad guy, this has been the past data, and based on this, the machine tries to learn, right? So data labeling is a huge challenge for many of the machine learning algorithms, right? So these labelers are on one extent, this is a blue collar job, because it acts, I mean, these people act as like utility people for rest of the roles. But on the other extreme, this is also a very, very domain specific role, right? So if somebody is working in, say, machine learning algorithm application in healthcare, right, you would be talking to real doctors, real microbiologists, right? if there's a vaccine that is being tried out, right? So you will be to label such data, right? To label whether an X-ray, whether there's a tumor in the X-ray, right? You would need a domain expert, right? So this data labeler role, till the time we don't have the automation of this, is going to stay and is going to proliferate even further. Okay. Now, a similar category is this box of roles, right? Which is in the area of say humanities and behavioral sciences and law and public policies, right? Ethics in machine learning, I'm sure you'll come across any time later in your careers, right? But ethics in machine learning is a very hot and very contested area, right? And then ethics is the very reason for which every time Mark Zuckerberg and Sundar Pichai, they are being called by the US Congress, right? So ethicists, lawyers, public policy people, behavioral scientists is again, people who are working in say non-profit sectors and all those things, but they are also, since they are also trying to leverage the power of machine learning, it's this category which is emerging as people who kind of know machine learning along with whatever law or public policy that they already know. Okay. Now this is the last row at the top. If rest of it, from below this market dotted line of the market was the company and people producing stuff, right? On the other side is the majority, right, which is consumers, and that's where all of us, if we decide not to do anything in life, if we decide to become a house husband and housewife, that's where we'll be sitting, choosing to buy a product. Okay, so these are the people who will be buying, Alexa automated home, self-driving cars, and all those, ML-enabled products, right? And if you can't know, if you don't know how it works, right? This is at an emotional level, this is going to cause frustration, right? You might just get locked up if you don't know how to operate, how to talk to a, Siri or Google Home or, Alexa Home, right? Similarly, if you don't know, if you don't know how to deal with the predictions of learning and AI, you, in all likelihood, you'll struggle, driving, managing, owning a self-driving car. In a way. So self-driving cars are never going to be fully automated, right? So again, another example of how, as a consumer, you are going to struggle a lot in this role. Okay, so I think. This is all that I could think of in terms of different roles, and I'll wait for your questions, any specific questions specific to any of these roles. But then this is what it is, right? So what makes the world of data science cool and amazing and magical is not really one person or one discipline. It's this complex web of different roles, right? That makes things work, look smarter, or acting as being magical. Okay, so again, to reiterate the first point that I started with in the beginning is that it's always your sweat and talent, right? To borrow these words from Guilfoyle. Okay, my video will be more helpful, right? Here, to make sense and to keep up with the changing sort of, starting from the, new research that is happening in the world of data science and machine learning, or emerging sort of new kind of roles. And then I can see, a number of questions that we'll take up at the end of this part one of the session, right? But then here comes the importance of a mentor, right? Having somebody. He could be your senior, he could be your somebody, some relative who sort of working in this field, could be anybody, right? But then it's better that you get things sort of curated and things that you can consume and comprehend in the way depending on where you are in life, right? So on that question of and I was wondering about who you sort of rely on, depend on for learning these things, other than of course YouTube people, right? Now these corresponding to these four states, right? These are four types for themes that a data scientist need to address and be balanced about, right? So corresponding to the use case, this is the problem, and then having a good eye on data, just making sense of huge data sets, and then of course for the modeling purpose, the tools, the kind of tools, the programming languages, the frameworks that you work, right? And then while the model is working, right, your analytical capabilities of if something goes wrong, who I should alert. Okay. Now, in usual courses or usually when you hear people talking about learning data science, most of the emphasis remains here on the tools part, right? Which language are you learning? Do you know R? Do you know Python? Do you know this? Do you know that, right? And very little emphasis on analysis or on data, and the least emphasis is on problem, right? What is the problem you are solving? Why you are solving? Can it be even solved by machine learning, right? Now, again, I've removed those sort of model stages, and correspond to each of these areas, right? This is how, if I were to choose, if I were to learn machine learning right, I would try to give equal emphasis to all these 4 problems. Now, again, to give you, again, an example of how can I learn about, articulating problems, figuring out which use case could be solved by machine learning, is only when you deal with the problems that are actually being solved in the industry, correct? And similarly, data sets, I'm sure you are aware of the kind of data sets that are available on Kaggle, right? Those are usually called toy data sets, very small data sets, and those data sets usually do not give you the complexity that you would discover in a real life problem, some industry use case. And then, of course, doing the so-called feature engineering, exploratory data analysis. Of course, I have not covered these terms. You'll come across, but these are all tools and your skills related to how you make sense of data, right? So if you deal with very small toy data sets, you will not be able to appreciate why these skills even exist in the field of machine learning, right? And on the tool side, you of course already know, right? Image processing, natural language, statistics, Python basics, any other programming language, right? And then analysis, again, in terms of what is working, what kind of algorithm working best in your production, and in case there's a problem, in the production, how to resolve it, how to address it, who to alert. Okay, so if one were to learn, if one were to become a good data scientist, I would look for these 4 elements, and all of them in like balanced proportion. And again, you could really build your own roadmap, from the information that is available on the web, YouTube or otherwise, right? You could choose a course, but even when you are analyzing that course, make sure that the course provides all of these 4 sort of buckets, right? And the course emphasizes on all of these in balanced proportions. Its course is not sort of highlighting just the Python and just the tools part, which usually is the case with majority of the courses. Okay, so I think that's all. All right, so I think that was a lot of yarn, I would say. And then with that context of how you should be choosing and looking out for a course, for the right course, give me a second, let me share another screen. I hope this is visible now. Yeah, so with that, that was a 3 or 4 segments of a lot of yarn that I thought of try to distill for you in various sort of segments, right? But that was easy. I'm sure that there are there'll be many people who you can get it from, right? what we have been thinking, and the last slide especially, which you might have noticed, that there is a real dearth of a balanced course that gives you a knowledge about a complete machine learning life cycle view of a problem, right? And that's what, in fact, one of the questions from the people who have registered, right? That was very interesting. It's like he's asking, I can't quote it, but then he's saying that in the courses we learn very very basic things about at a very beginner's level, right? But when we go for interviews and for either jobs or internships, right, we are expected to know a lot, right? And not just in the on the tool side, but a lot about how to deal with data, how to make sense of a problem, or even what happens to a model after it is prepared, right? What is the afterlife of it, right? So keeping that in mind, we have been thinking and designing a course which would be little balanced across all these 4 aspects that I mentioned to you in the previous slide. And this is what you see on your screen. So it's just a preview of what you can expect from the course. We are going to have it available in sometime in January, 1st or 2nd week, January 2021. Price is sort of to be disclosed at some later point of time, right? And these are some things that we are planning to cover. We are going to have like 30 plus hours of videos, which is not too much but not too little. So it'll balance on the content part. At the end of the course, you are going to have a internship, which is through which you are going to get a real exposure of working with Transsolve, right? And then there are going to be other sort of features in terms of group learning, social learning, and and then in terms of assignments that you are going to get as a part of the course, the projects that you are going to complete, either in terms of internship or otherwise, and the throughout the course, even after the course, the kind of mentorship that you're going to get is from people who work every day on real industry problems, right? So that's going to be a very short review of what the course is going to look like. We are putting a lot of effort and care in choosing what to tell you, what not to tell you. In fact, one of the participants during the presentation asked, are you going to use this data, the polls data, right? Of course. I mean, we want to learn, we want to ask you as to what you expect from a course, right? There are many courses that are already existing, right? But then we want to make a course which actually is up to your expectations, which actually fulfills your needs based on wherever you are, first year or second year, right? So if you have more inputs, your email IDs are with us, and we'll be sharing more sort of opportunities through which you can tell us, you can be a part of the course making journey, literally, right? And you can be a part of that group and tell us what will make the course an awesome offering, right? So I think with that, that was it from my side, telling.